Recording. There we go. Good. So now we're on question 57. All right. You remember their strong acid, strong bases, 100% breakage. All right. Weak acids, weak bases, they don't have 100% breakage. Sorry. All right. Very good. Strong acids or bases, they have 100% dissociation. They break apart. But weak acids, weak bases do not. 50-50, right? Where they break, we don't know. That's what makes them weak acids. And I want to know the concentration. So let's have a look at 57. Here I have hydrosulfuric acid. Hydrosulfuric acid is a weak acid. Okay? The Ka value for it is 9.5 times 10 to the negative 8. We're looking for the hydrogen concentration. All right, good question. You'll see it. All right. Now, what is happening here? I didn't even give you a chemical equation. Well, now you're going to have to make it. So, okay, it's going to equal H3O plus, plus S2 minus. Now, is that balanced? What's going on here? H2S and that, I got 1S there, I got 2, and I got 4, so probably we'll need 2 of these. How do we balance this? What's going on here? I got a balance. I got 1S, I got 1S. I got 1 oxygen, I got 1 oxygen. I got 2 hydrogens, and I got 2 hydrogens here, so that means, how would we balance this? Anybody have an idea? Actually, let's just take a minute, and can you balance this? H2S, H2O, what do we got? How are we going to do this now? So, this is what we got here. And remember, this is your acid. This is your base. Acid, which one is going to give hydrogens? This one here. And you remember your conjugate acid, conjugate base. Which one here is going to give a hydrogen on this side? This will be your conjugate acid. This will be your conjugate base. Before I forget though, since I've got this on recording, do you remember what your K values mean? When you have K is much greater than 1, when K is roughly equal to 1, and when K is much smaller than 1. Okay? If K is big, even like 2.5, 8, 800, 8,000, that means that this reaction is going to be over here somewhere, product side. If K is really small, 0.2, 0.002, 0.000002, this reaction is going to be here. Because we don't know where it is, because this is a weak acid. We don't know where it's going to hang out. Strong acids, there is no double arrow. Strong acids, strong bases, choom. Which is why we have a Ka value. It'll tell us where this is. K values that are around 1 means that it's 50-50. I would know that one, okay? So here is our chemical equation. Molar ratio 1, 1, 1, 1. And what's happening here now? It's asking me to find this. You remember your x squared? That's what's going to happen here. Now, I just want to show you something. Be careful. You have to be aware of what's going on here, especially for K's. You've got to be aware of what's going on here. Because remember, solids and liquids, we don't include in the calculations. So, any type of K question, I got to put products over reactants. So, Ka is equal to products over reactants. Don't include the water. It's not involved in this. Okay? It's a liquid, doesn't get included. Alright? So now you just plug and play. What do we got here? What was that? Sorry, I missed some information here. This is a 4.0 molar solution of H2S. So now you just plug and play. I have my Ka value, 9.5 times 10 to the negative 8 is equal to X, and X all over 4.0. Now remember, we're looking for this one here. I don't know it. But remember there that whenever one of these guys breaks, okay, I'm going to produce one of these and one of these, so these values will be the same. All right, so that's why this will be X squared. All right, and now you just solve away and away you go. Okay, so X squared will be equal to 9.5 times 10 to the negative 8 times 4.0. And then you square root that answer, and what's my answer? 57. I got an answer of B. Okay. Ka definitely is on there. It's on the quiz as well. Okay. There is some work to do. Like, a silly question. Like, what is it? It's barely a line long. But look, you had to make this, you had to make this, you had to know that this is X squared, and that's how you do these ones there. Okay? For all Ka, that's how it'll be. I'll be looking for this one, or I'll be looking for Ka. Okay? That's how these ones go. What else we got? Any more comments? B. I'm really glad if you all got to go, it's all good. I'm just going to keep on going, and we'll record this and I'll send it up. And please ask questions. What else you guys got? We got 41. Perfect.
Really quick, on the question that you just did,
yes. What do you got?
The 9.5 times 10 to the power of negative 8 times 4. What's on the bottom of it?
Well, good. So sorry, I apologize. I kind of moved fast. What I did was this formula right here. Are you okay until this point?
Yeah.
Okay. So then I just rearranged the formula there to solve for X. So X squared divided by 4. So what I do is I multiply this side, and then you see how that cancels. So now this is the formula rearranging, right? So now we have X squared is equal to 4.0 times 9.5 times 10 to the negative 8, and whatever that equals, and then you square root this side, square root that answer, and that's how you get it. I think the answer is B. How's that? Is that okay, Shaylin? Or I apologize, I didn't mean to go too fast.
That's okay.
Is that okay? You see where everything went?
Yes.
Okay. I don't know if you guys can see that or not.
So you square root the 4.0 and then you square root the 9.5 times 10 to the negative 8?
Yeah, because you got to because we're looking for X, right? Like the question says find the hydrogen. And it's a good question. It really is a good question. We're looking for that value. But I don't know that value. Like, we'll call that X and we call this X, just to kind of put them together so we only have one unknown, because both of these values are going to be the same. And So we have x squared here, which is that times that. It's okay for now, but at the end, we've got to square root this and figure out for x. So let's do this here. Let's see if it goes. 9.5 exponent negative 8 times 4. So I have x squared is equal to...
Okay, I just did it. Now I understand.
You're okay? Hey, man, that's all good in the hood. I love it. I love understanding. And you asked. That's exactly, the process works. I love it. So now I got that, and then square root answer. Yeah, 6.1 times 10 to the negative 4. Is that even know the right answer? Yeah, it could be. If it's not, let me know. I wouldn't be surprised if there's more than one error in here. I've been at it and I can't do it anymore, so I'll let you guys tell me. We did have a 41. Good question. Thank you, Shaylin. All right. I really gotta get me some wipes. All right, let's go. 41. So question 41, what is the concentration of nitric acid, which is a strong acid, by the way, if 10 milliliters of the solution is neutralized by 3.6 milliliters of a 0.2 molar solution? So, I don't think you guys have to do this, but I'm just going to do it just to show you. Nitric acid plus sodium hydroxide, acid, base, water, and a salt, which would be sodium nitrate. All right. And is it balanced? I think it should be balanced because it's all 1, 1, 1, 1, 1, 1. I think it's good. Yes, it is good. Now, what is it asking? So, what is the concentration? So, we're looking for molarity. Okay. And I got 10.0 milliliters. And here I got 3.6 milliliters, and I got 0.20 molar. Now, I don't know who asked that. Whoever asked it there, when you get to this point here, you look at the information I've given you, you look at the information there that I'm asking for, you go to your formula sheet. What do you have that has molarity and volume? Molarity and volume. Well, it'll be M1V1 is equal to M2V2. Okay. Molarity, we don't know. The volume, change it to liters. And if you got milliliters, just divide by 1,000. Because there's 1,000 milliliters in a liter. Okay. So that would be 0.010 liters. M2, 0.20 molarity, and I got 0.0036 liters. I'm just doing that quickly in my head. All right. And get rid of this guy, bring it over here. This is molarity times volume. So you divide on this side, divide it on this side, so it goes down here. Okay. See, divide on this side and this side here, it will cancel. Okay. So M1 is equal to this, whatever this equals. How are we doing? Is that okay?
Do you have to switch it to liters, or is it fine as long as like they're both in milliliters or both in liters?
I'm going to lie to you and say yes, you need to change it to liters.
Okay.
For a couple of situations that I'm not going to tell you about, but just switch it to liters just to be safe. All right. And yeah, that's all I'm going to leave with that one, because I could go on and tell you things and then you just become, doesn't serve your purpose. So yeah, whenever I give you something like this, just change it to liters, quick like a bunny, and then you're done with it. Okay. I think there was another one, 51. I didn't figure. Sorry?
Sorry again. Just make sure you got A, right?
I have no idea. Let's try it.
0.072.
Is it on there? Let's have a look. 0.2 times 0.0036 divided by 0.01. You got it, 0.072.
Okay, perfect.
So that was A?
Yeah.
Perfect. For all of our viewers at home. Boy, I should maybe look into getting my own YouTube channel. I don't think it'd be very popular though. 51. What do we got? 51 is a KEQ. I love it. Let's have a look here. What are we doing here? Yeah, you know what? We'll do this question here and then we'll take a $5 so I can go and make sure my children I can hear them walking around, so they must be breathing. So here we go. This is a KEQ question, 51. I like it. Don't even need to write anything. Which KEQ value indicates the greatest concentration of products? So you have A plus B produces C and D. If you have a big K, it's going to be this side. If you have a crazy small K, it'll be this side. And if you got K around 1, it's 50-50 here and here. So looking at this question right here, 6.7 times 10 to the 5, 3.2 times 10 to the 9, 1.4 times 10 to the negative 3, 3.2 times 10 to the negative 7. We're looking for which number represents the greatest concentration of products. What do you think? Look for your highest number. Okay? In that case there, it would be B. What else we got? Any more in there? So we don't add volumes, So we don't add volumes? If someone wants to elaborate on that question, I could answer it. Well, let me know. Let's take a 5-minute break, and I'll be back. I'm going to stop recording right now. I just want to check on my kids, and then I'll see you guys in 5 minutes, and we'll continue on. Okay? Give me a couple minutes here. There we go.